Good morning and welcome to our webinar. My name is Odette Hines and I'll be your moderator for the webinar entitled Learn How to Run Sony Spresense Microcontroller with NuttX. Your presenters today will be Armaghan Ebrahimi, who's a partner solution engineer at Sony. She works with different divisions at Sony to bring innovations to developers and businesses to build scalable solutions. She has over 20 years of experience in the high-tech industry with a mixed background in hardware and software engineering. She's also worked on chip-level verification on ASIC and FPGA all the way through to the video player on Android and iOS devices. She supports Sony's presence in North America. Our next presenter is Kamil Tomaszewski, who is an embedded engineer at Sony. He's one of the major contributors to the Spresense technical support team. He has supported CircuitPython on Spresense. He also supports Spresense documentations, built demos, created tutorials, as well as constantly interacting with customers and developers who might have technical questions on forums at all our events and webinars. He supports Sony Spresense globally. Before we start today, I want to provide you with a few housekeeping rules. All participants are in listen-only mode. If you have questions during the webinar, please type them in the question section in your Zoom control panel, and I'll ensure that they're answered at the end of the webinar. If we do not get to your questions today, we'll send you the answers to you a few days later. The on-demand version of our webinar will be available within the next few days, and we'll ensure that that is sent to you as well. If you require a conversation or a demo, please ensure that you put that request in the question section of the Zoom control panel during the webinar, and I'll ensure that they're directed to the presenters at the end of the webinar. Now, without further ado, I'll turn it over to Armaghan. Armaghan?
Thank you so much for that. Hi, everybody. This is Armaghan Ebrahimi. I will present Sony Spresense programming with NuttX today, and my teammate Kamil is helping me with this presentation. So let's start. The agenda for this presentation will be brief introduction to Spresense for those of you who hasn't got a chance to work with Spresense, and also I will touch on NuttX. What is NuttX? And then I will go through the steps how to set up your environment, run your first Hello World program, and then we focus on different features of Spresense like camera, GPS, and also audio, how you can program it with NuttX. I will talk about next is going to be multi-core and ASMP Framework. And at the end, I'm going to briefly go over the AI library for Spresense. So first thing first, let's talk about the Spresense and see what is Spresense, Sony Spresense microcontroller is. Spresense has high resolution audio. That's one of the characteristics of the Spresense, and it has the GPS integrated in it. Also, you can connect a camera, as you see in the picture on the left-hand side, you can connect the camera easily to a Spresense to build your application. But this microcontroller has six cores. You see the specs on the left-hand side. It has 6 cores, 156 megahertz of clock. The memory is 1.5 megabyte, and we also offer the flash memory. To access the board, you can access via digital input and output like GPIO, SPI, I2C, UART, and PWM. We have the analog input, which is 6 channels, 3.3 volts. We have audio input and output. We have 8-channel digital and 4-channel analog mics, and also a speaker is another output that you can get from the Spresense. Other features, you have the camera interface. Easily you can connect the camera to the board. We have access to SD card. For example, for audio, you can save your audio there. And then you have I2S access. I will refer to these features, and I try to go over more detail when we get to the sections that we talk about this. To show you the component of Spresense, we have in the Spresense kit, we offer 3 components. We have the camera board, main board, and extension board. As you may guess, main board is the brain of this kit. Everything is happening here. Now let's look at the right-hand side of this page. So we have the main board. There are two chips on this main board. One is the CXT5602. You will hear this from me when I go over this presentation today. And then we have also CXT5247. Each of these chips are responsible for different functions, as I listed here under the name of this chip. For example, for 5602, we have high resolution audio codec available on this chip. Or for CXT5247, we have the Class D full digital amplifier available. Just to give you an idea, what is camera board, extension board? It's just to make prototyping faster, easier. And for the camera board, is easily you can connect it. You see here, and I will show more information. This is how you can connect the camera. And then for the extension board, you have the micro SD card access. You have an output for audio. You can put Arduino shield on top of this, and this is gonna again make the when you build your application, is helping with making that easy. So now let's see how you can develop with Spresense. This is showing you the software stack of Spresense. This is showing you the development with Spresense. If you look at the different section, let's start with the bottom part. Bottom part is the hardware. So you see here that we have the chips and we have all of the hardware in the pink section. And then we go on top, there is a green section. This section is the Spresense SDK. And the Spresense SDK, as you see in this picture, is built on top of NuttX real-time operating system. And then the focus of this presentation is going to be this section. So when I say audio, video, GNSS, ASMP, everything is in this section. And as you can see, the Spresense SDK is built on NuttX, but we provide support for Arduino libraries as well. And we also support CircuitPython or Micro EJ also, and the other third party. But the base is NuttX. I have webinars for CircuitPython and Arduino if you're interested as well. But for this presentation, we focus on NuttX. Let's see what is NuttX. You may heard about it or may not, but what I want to tell you is NuttX is nothing but similar to Linux, but it has much reduced feature set targeting microcontrollers. As you can see, you can tell, microcontrollers, they don't have a very big memory. So that's why there's so the instructions and commands, everything is like Linux. If you know Linux, working with NuttX is not going to be very difficult. So NuttX is nothing but a real-time operating system, and is scalable from 8-bit to 32-bit. And the primary standard for NuttX is POSIX and ANSYS standard. If you want to learn more about NuttX, there is a community forum, everything around it. You can find more information under NuttX here, the link that I provided here. You can get more information. So now we are going to that section that I said we are going to focus on. It means we are looking at the Spresense SDK here. Everything is built on top of NuttX. Here we have all the NuttX driver frameworks and all the drivers, and basically this section is all the drivers. And then we have middlewares that's sitting on top, and this is your applications. So your application sitting on top, and then you have these sections to program it, and then the base of everything is NuttX. This brief introduction is done. Let's start and see how we can set up our environment and for Spresense for NuttX. First of all, let's mention this. Operating system that we are supporting is Linux, Windows, and Mac OS. I have provided the link here if you are interested to set up your environment for any of this. The step-by-step is very easy and simple. You can go through this instruction and do that. This presentation, I will focus on the setup for Linux and is a command line interface. you need, so now let's focus on the setup. Setup is nothing but 3 steps. You need to do the serial configuration. As you see in this picture, this is our Spresense, and this is the cable that you need to connect to your PC. And so for that, you need to do the serial configuration. Then we need to install the development tools, of course. And then at the end, you need to clone the Spresense SDK on this board. These are the 3 steps that you need to do. I will show you the instructions, but I'm not gonna go through the detail. This is in our documentation. So it's you run this command. As you see, it's very similar. This is Linux. Yeah, if you know Linux, you can figure this out. So you go through these 3 steps as I show here, and by the end of these steps, you are ready. Your environment is set up, and you clone the Spresense SDK. Next step is for any environment, we need to test it. So here we run the Hello World program with Spresense. For that, these are the 5 steps. So you need to configure the instruction for this program, and then you need to build it. When you build it, you generate a file called NuttX SPK. So anytime you build any application, you will see this NuttX SPK, and you need to flash that on your board. So this is very, this is going to be, this applies to other sections. So I'm sharing with you here. So then you flash this on your board, and then of course you need to run it, and you need to show the output. Again, let's look at the commands and instructions. What you need to be aware of when you start doing this configuration, you need to be in SDK directory. So when you clone Spresense, you generate this folder, Spresense, and then under that is SDK. Go switch directory to SDK, and then run this command, the rest of the commands. So this is the config.py, which is configuring, doing the configuration. As you see here, I have examples /hello. For the other example, you see examples /GNSS or audio or recorder or player. So this is very similar for the other sections also. And then you need to build it, you do make. And as I told you before, after you do make, you see this NuttX SPK file generated. After we do this, we need to flash the board with that. This is the command that you do for flashing the board. The /dev TTY USB, this is your USB cable that is connected. And then you have the NuttX.SPK that you put it on the board. You see this output, and when you see reboot means you are done, and this has already been flashed on your board. To show the output, like you want to type hello, and then you want to see hello world. I am using a screen here, so you see the command to install a screen. You can use any others than a screen like Minicom or others. Here is just the instruction for a screen. So we do this, install the screen and connect to it. For connection, again, we need the USB. And then this is the baud rate that we require. It depends on your setup and all, but this is what we need here. And after you do this, you see this nutshell command line, as you see NSH here. Here, if you type hello, you see hello world. This is your first program. It's so you have the setup. You run the first program. Now you are ready to do to work with features like characteristics of Spresense, like camera, audio, and GNSS. So this section is going to tell you how you can start with this. But before I start, I just want to tell you each of these are very big topics. I'm not going to cover everything, but I make sure I provide enough links and information for you to start with. And then you can also, ask questions on our forum and other resources that we provide. You can start working on your application. First thing first, let's talk about camera. So as I told you, camera is, it was very easy. You just slide the camera in Spresense. It has a slot for that. So let's talk about the hardware, and then I will cover the function for the camera. For the hardware, hardware is, you look at this picture. CXT5602 is our chip. I remember I told you at the beginning. And we have this camera. This is the Sony camera module called ISX012 that is mounted on top of this chip. We are communicating with this camera module via I2C, which is gonna do the control. And then we have the 8-bit parallel communication for data. So this is what we have as far as hardware. But for the function, if you're familiar with Linux, V4L2 is video for Linux that is to support video on Linux. Here we have something that is V4S, Video for Spresense, which is similar and is compliance with V4L2. And if you look at this picture on the right-hand side on in the bottom, so we have this when you go to dev video, and so this is gonna give you all of the subsystems, so to support the device, which is the camera that I told you. And V4S2 provides abstract APIs of camera functions by using standard file system interface like open, close, and IOCTL, so or IO control. So you see here I have V4S, so Video for Spresense, similar to V4L2, but it has its own characteristics. So for example, when you use the V4S, please pay attention and make sure that the frame buffer of the image is allocated. So this is something on the user side. The reason that you're doing this is to make sure you are managing the resources for memory better. And then if you look at the picture again, for this V4S, we have two types of a stream. One of them is the video stream, the other one is for the picture. For the video stream, we call it video capture, and for the picture, we call it still capture. So I refer to these two names when I talk about video and still picture. So what you need to consider is when you work with the video stream, you need to basically process and perform. Then you have a guarantee the frame rate. So this is for the video. And when you're working with the picture, you need to make sure that it has the high resolution. And that's why the processing is different for each of these. And it may take longer for processing the picture because you need to get high resolution. Knowing this basic about the camera, let's look at the programming, how we program the camera. For the camera, basically you initialize the video and open the device. These are the commands that you do that. And then the next step, you need to use the IOCTL, and you do the setting the number of frames, setting the pixel format, and then also turn on the stream. So these are the code I put here for your reference. Then you know where to start with. But what you need to pay attention is the type, because we said we have two types of a stream. It could be a picture or video. So here, when you have the type, you can select is a video or is a picture. And then for the pixel format, we have different type. We have RGB 565 and YUV422 and JPEG. So these are the formats supported for the video and picture. And then the processing, as I mentioned before, for video and still capture is different. So it depends on the if you need to guarantee the frame rate, if you need to have a high resolution. So pay attention to that. Let's talk about the image. So now we learn how to process the streams, and then you need to retrieve this image, right? To retrieve that image, if you look at this picture, it's very straightforward. You just need to do the QBUF, means you are dedicate a memory to save that picture there, and then you use dqbuf to retrieve that. And the steps to set the memory is written here, and then you're extracting, or then you can get that image from your, you can get that image following this instruction. I am done with this camera section. I have provided 2 links here. One is the documentation, the other one is the GitHub to build, to get more deeper, so you can use this documentation and look at the sample code that we provide for the camera here. For all of the section, I provide this, so that's because you can get more deeper and learn more. Let's go to the audio section now. So for the audio section, we support different audio system. You can do audio player, recorder, you can do audio mixer, or even you can do some control for the hardware, codec hardware control, or work at the DSP level. For the audio player, we have 2 instances, and also you can get the output from the I2S or speaker. The type of waveform, the type of format of the audio, it could be wave or MP3. For the recorder, you have 4-channel analog, and you have 8-channel digital mic that you can access. Channels are interleaved in PCM data, and it can be stored in linear PCM or MP3. Audio mixer, you see it in my next slide, is an object that you can mix the audio. And then for the codec, you can do different things that I have. For example, I have listed volume and noise cancellation and so on. You can get to the DSP level also and do custom audio processing as well. Let's go to the next section. So for the audio system, you see the application on top, and then you have the this diagram. I will focus on the first level for application, and then we have high-level API and object level API. Mid-level component and audio driver is sitting here to support these two. What you need to know is we have high-level API, means you are using the audio manager, and then we have object level API, which means that you can set up objects separately, and then also you can do direct communication with each object. It's more flexible here, but it's more complicated. So this is what is a flexibility that we have. If you go to audio manager, is more again, you set up the object separately, but all the communication is happening via this audio manager. Okay, so now I show you a simple, I show you a data flow of an example. If you run an MP3, playback an MP3 on Spresense, this is very high, using high-level API. High-level is when you use the audio manager. If you look at this picture, we have different arrows coming and going. So this is nothing but having an MP3 coming from the FIFO, and it goes through different components and objects in the audio system, and then at the end you can hear that audio. So as you see, so I have this this section is the media player object, and then the other section is output mixer object. For this one, we use the decoder. So audio go to the decoder, then it's DSP, then I generate the PCM data. Look at this arrow, so it explains like, so then I have the PCM data, then it goes to next section for the output mixer object. And then if we need to add any filtering, and then again it goes to audio DSP. And then finally, this PCM streaming is gonna be fed to, it's gonna go to the speaker or headset via DMA. This is just to show you how we can play back and then what is happening inside. These are very, it just shows you the different steps that you need to do for high-level API, and also my next page is for object level. These two are the same. So these two are the same. So I'm following these 4 steps, means I have to create the components and specify the parameters. We need to do power on hardware, create a FIFO, and also start the player component. The instruction is 1, 2, 3, 4 is sitting here. The only difference that I can tell you here is basically when you have between these two, as I mentioned before, of course, the control is when you use the other one, you have control for the audio. Audio manager is controlling everything. But when you do object level, you are controlling everything. But for this one, you need to do everything yourself. Like if you want to active a player, you have to say AS_active player. Or if you wanted to start the mixer again, you have to send the command yourself. So this is more flexibility, but it depends on your application. This is something that you have access to for audio. The last slide for the audio is the suggestion is make sure that you are doing the resource handling correctly, means the memory, and also be careful with the message queue. As I said, if you are doing the control yourself, be careful with message queue, but don't worry, audio is a very complicated concept anyways. But if you go to our documentation, we have sample code for each of these. So start with the sample code and build your application, and then you can have a good base to start with. So I'm done with the audio. Let's go to the GNSS. GNSS is a global navigation satellite system, and this one is Spresense has integrated GPS in it. You can target drone application. Any logistic transition application can be supported by this GNSS. Our GNSS is supporting all over the world. So we have a GPS and all the way to QZSS in Japan, GPS in the US and all. And then, and you can have up to 2 satellites. And what you need to know about our GPS is not only positioning, but it's geofencing. Geofencing means you have an area you can enter, you can support the function to enter to this area or leave this area or dwell in this area. So that is the characteristic of our GN. Oh, and the important thing is the antenna is already here. So you don't need to add an antenna for the GPS. And then if you look at the application level for just the structure, we have the application level. And then this is our GNSS driver sitting here. Same concept as a camera. So we are communicating with this, doing all the setup and communicating with this via this device file. And then we can do open IO control, read, and sig wait, which I'm going to touch on these things. Also, we are using the POSIX signal. POSIX signal is just to read the positioning result, because when you request positioning, you need to make sure that you get that. If you don't get, you try again. So this is for the GNSS. These are the 5 steps that you need to do for if you program the GNSS. Just briefly, you need to open the device, is the /dev GPS, and then you use POSIX signal. Then you use IO control to start positioning. You use sig wait info to get the info of the signal, and then at the end you read the position. Let's look at the example. I have provided just the instruction. This is very similar to the hello world that I told you, but look at this. So the example now is GNSS. The rest is the same. So you need to go to the SDK directory and you need to do configuration, build it, generate the NuttX SDK, and at the end you can read the data. So you can, when you type in the nutshell GNSS, it will show you the data. The signal positioning and all the information for the GNSS. So if you need more information, please refer to the documentation and code that I have provided the link here. Let's look at the multi-core and ASMP framework. This is, Spresense has 6 cores and 156 megahertz of clock. You need to take advantage of that to do, for your application. Here we are showing how is possible to utilize all this and what we are using. We are using ASMP Framework to utilize this multi-core for Spresense. If you look at the Spresense, we have 2 you need 2 tasks here. One is the supervisor task, the other one is the worker task. Supervisor is in main CPU, and worker task is different cores that the co-processors that you assign them as being the worker. And you communicate with ASMP framework. You use a different type of messaging between the supervisor and worker. We support MP message queue, mutex, and also shared memory. And so this is a very classic concept that we have supervisor, or we have the worker supervisor, or other, we have slaves and whatever. So we have the communication with the ASMP framework, but you need to learn about you need to know about the memory also. If you look at Spresense has 1.5 megabyte of memory, and is if you look at the memory, is just the size of 128 KB, and we have 6 cores. The blue one you see is the main core, supervisor core sitting here, and then the rest, the 5, can be worker. You can use 1, 2, or all of them. What you need to be aware of is how to assign the memory type. You can use only 1 for each core, or more than that. It depends on your application. Again, you can use 1 core or 2 core or all of them. Then you need to be aware of how you assign the memory, or how dedicate memory to each of this. Or if you don't use any of the cores, then everything is going to be used by the kernel. So this is for the memory. Just keep in mind 128 kilobyte is the memory types. For that, this is just showing you how we manage this worker task startup sequence. This is very simple. First, you need to initialize it, and then when you initialize, you assign a worker. When you assign a worker, then you need to prepare message queue and allocate the shared memory. This is the next step. And then you start executing the task. And then when you're executing the task, this is going to go to the parallel processing and start executing on the worker. And then this communication is happening until you are done with that worker. Then you can destroy it and stop it. When you destroy and stop, if there is a message or shared memory that was created for this one, also that's going to be discarded. This is the concept. And also the other thing that is good to know about the worker task is the format of the file is a ELF format, and it has to be contiguous. It starts from the address 0 and it continues, and then the next one is going to be after, like, it depends how much you need here. But what you need to keep in mind is this worker task is going to have an ELF format. And so now let's see what I have. My last section is the AI and AI library and DNNRT. So DNNRT is our supporting for AI on Spresense. This is just showing you the general concept of when you want to do AI. What you do, you have a database, or you have a data set. I'm sorry, you have a data set, and then you train that data set, and that model is going to sit on your device, and then you have some input data, you do the inferencing, and at the end you do some recognition, like if this is a cat or dog. This is the basic concept of AI. What we do here, we have a neural network console by Sony that is all GUI based, and you can train your model and generate the file, file for Spresense. In the next slide, I show 2 things to you. The example that we have for the DNNRT is a handwritten number recognition. I have provided the link, for example, here, and also the documentation. This is just to show you what is happening inside this code. But the most important thing is when you use the NNC from Sony, you need to generate this NNB file, and then that file, it comes to Spresense, and then you do your you use that one as your model. But if you want to learn more, I had a 1-hour webinar about this, Spresense and an AI. you can just go to this. I provided the link here. You can go there and learn about it. And the other information about what is Neural Network Console or the library or what is Nabla C runtime, just use these links. The exciting thing is we are supporting TensorFlow, and we are going to have a webinar about Spresense and TensorFlow very soon. I am wrapping up my webinar here. I just want to show you some of the links that you can reach out to us or communicate with us. Spresense website is here. If you are interested to learn more, please go there. Our Twitter has all of the new news and webinars and all of the activities. You can follow us on Twitter. If you have any application that you think Spresense is a good fit, you want to start a conversation with us, we can support you to give you information, send you some boards. Please make sure that you contact us here. We have a forum for your questions, and we have you can ask questions, we answer you here. Our YouTube channel has all of the webinars, short videos that you can start with Spresense in 4 minutes, for example. And also our partner is Framos. If you need to talk about sales and buy a Spresense board, make sure you contact Framos. This is the link that we have other distributors like Adafruit that also you can get some boards and add-on boards supporting Spresense there. At the end, I wanted to tell you about our new partner, Edge Impulse. And the Edge Impulse is providing a platform to build your AI application really fast with Spresense. This is all I have. Plus, there is something that we have a new camera coming soon. So, which, well, we will share in our next webinars. This is all I have. Thank you so much for your attention. Odette?
Thank you, Armaghan, and thank you to all who stayed with us throughout the webinar. If you have not submitted your questions yet, please do so, and I will get to them. We do have quite a few that we need to get to today. So let me start by bringing Kamil on the line. Just want to make sure that he's there. The first question that I have is it possible to set the camera for motion detection? I mean, putting the Spresense to sleep and waking it up when massive changes on the images are detected by hardware.
So I can answer this question. So unfortunately, there's no such a feature for the camera, so it's not possible.
Okay. This is another one too. You mentioned the new camera, Armaghan. Somebody basically said a new camera. I need the details. So we will provide that at a later date.
Yes, it's very exciting actually. This camera is you can it has better capabilities, and as the current one, it has the same interface and everything, but it has more capabilities. You can do I will share. Maybe we have a webinar.
Maybe we need a webinar for that. Yeah. I was about to say that. Okay. Another question I have here is, how do you use custom Python model for AI? I think you covered quite a bit of that in your last webinar you did on Spresense and AI. But if you want to elaborate some more, I think it's good. And then there's some other follow-up ones to this. So I'll let you answer this one first. So the question again is, how do you use custom Python model for AI?
Yes, but I think for this question, we had a separate webinar about this. So I think the best here is just to take a look onto this webinar or just go to our website and see, because we have this DNRT library that can work with the Nabla framework. So I think the best here is just taking a look to the previous webinar about the AI.
Okay. Another question is, can we use ADC input for audio processing? And he summed up to say he's using a hydrophone.
Yes, I think you can, but I think I will need more details. I mean,
Okay.
of course, you can do something with the ADC, but I don't know what exactly you would like to do. Yes.
Okay, perfect. Someone had asked if the presentation will be available after. Yes, it will be available after. I will have it sent out to you within a week or so. So keep your inbox open or your eyes open on your inbox to see that. I do have
And
a few.
also, yeah,
Go ahead.
sorry, Odette. We post everything on our website, and if you wanted to
Mhm.
get the slides for any of this, you can make a request on our website as well.
Okay, perfect. I do have a couple more questions, probably another 3 to 5 more questions. Is there any IDE available?
Yeah, for the NuttX, you mean, huh? If it's
Yeah,
for
let's see.
NuttX, I think I have provided the link. Let me show you. So you can use the command line, you can use the IDE, and this is the IDE link. If you go to my presentation here. So this is how to start. You see in the bottom, Spresense SDK getting started guide IDE. So you can use this link and start if you are interested in that.
Okay, I guess what we'll do next week is we'll send out the links as well, Armaghan, to the entire group so that they'll have access to it so they can click on it. So keep your eyes open for that as well. That will come. Another one that I have is, can I run my application without using Nutshell?
Yeah, so that was the Nutshell was just for accessing the screen. You see, let me just go back. So that is just a way to show your output. Let me go to the Hello World program. And that is, you can use anything that you want. So here I set up the screen. A screen is just showing your output. But if you want to use Minicom, if you want to use anything else, just go for it.
Okay.
Yeah.
And another one, do all cores run NuttX OS? I think this is a really good question too.
Yeah, Kamil, please take that.
Yes, so the NuttX OS is only running on the main core, and on other cores, there is no OS. Yes, so there's bare metal.
Okay. All right, and then can I write the code in C++?
Yeah, so I can answer yes. So Process SDK offer C++ support, so you can.
Okay, perfect. I think that's the end of my questions. Actually, am I seeing any more here? Someone says, just give me a quick second. We're working with Sony India. We use hydrophone input after preamplification. We've heard that using hydrophone to audio interface might cause impedance matching issues. Do you know anything about that?
Let us take this back to our audio experts.
Okay.
And I will try is it possible for you, how can I reach out to this person?
The specific person, I will get you their contact information and I'll send it over so you can actually reach out to
Yes.
them. Okay. And then the other one, this is probably just another, I guess it's, I wouldn't consider it a question, but they're saying the visual code as a presence extension, which is very handy. I guess there is documentation on the Sony site. I would answer yes, but I'd let you take it away, Armaghan.
Yes, that's yeah, it's available.
Perfect.
Correct me if I'm wrong, Kamil, right? We have the visual code.
Yes, I mean, this is our IDE that we have extension for the Visual Studio Code. So you can program Spresense, you can debug Spresense, or you can flash the code, or you can configure SDK and other.
Okay, perfect. And then the last question was about the TensorFlow webinar, of which I think a lot of people are interested in that. So I think it is, I think it's sometime in the next couple of months. Do you have a date already planned for it, or do you have the month? So at least we can get people.
We are thinking about October. Keep an eye on our Twitter and web, our announcement and news on our website. Yeah, we are very, very excited about that. But can I ask something? I see that people are interested in the camera. If you are interested in camera, can you send me your, like what kind of application you want to build with the camera and what you need, what feature of the camera is important to you? You can communicate, you can send that to Odette, or you can go to our website and communicate with us. Then we can collect that and see if we can address that with the new camera that we have.
Okay. That would be good as well. If it's easier, you can probably just respond to your invitation. It'll come directly to me and I can forward it over to Armaghan.
Oh, yeah, that's
I think
it.
that's
Yeah.
probably another question is the estimated date for the new camera. I think that
Yeah.
that will come as well once we get the information over to
Yes.
you.
Yes.
Okay. All right. So I will just wrap it up right now. I think we've answered the most of the questions that I've gotten, whether it be on the question section or, you know, by email, of which I got quite a few of those as well today. Thank you for sending those. We appreciate those. And I just want to reiterate that we will send you the slide decks, a couple links that were in the presentation today. We will get those sent over to you. We'll also send you the on-demand version of the webinar in the next couple of days. So just keep your eyes open on your inbox. And just one more thing, if you guys can do this for us, is to follow Framos and Sony's presence on LinkedIn, Instagram, and Twitter for more company information, any product launches, webinars that are happening, or any virtual events. Please do contact us there. There's also the Sony developers forum that Armaghan spoke about. If you want, you can go ahead and there's information in there for you to follow as well. And I want to say thank you so much again for staying with us. We appreciate your time and you have a great rest of day. Bye-bye.
Thank you so much.
You're welcome. Bye-bye.